I am continuing the question answer of the chapter pressure, and this is part 4, and I think this is very helpful to the student who are preparing for the examination. Let's have the question. First question, what is upthrust, which is also called buoyant force, a resultant force acting vertically upward on a body when placed in a liquid is called upthrust or buoyant force. We have to remember that this is vertically upward and force which is measured in Newton. Okay, it can be understood very nicely with the help of this diagram also. Let's say we have water in a vessel, and if a body is first weighed in air, let's say its weight is 5 Newton. Now we are going to immerse this body into water, and when it is immersed and again weight is taken, then what is found is weight is found to be reduced. And let's say its weight is reduced to 4 Newton. Now 1 Newton is lost. Why? Because the water exerts an upward force on the body, and this force must be 1 Newton, which is reduced in the weight. Okay, this way we can understand upthrust. Okay, let's have another question. How can we measure upthrust? Write down with formula. We can measure upthrust by simple method, that is, at first, the body should be weighed in air and then in liquid. The difference of weight is upthrust exerted by the liquid on the body. Very simple, and it can be represented by this formula: upthrust equal to weight of the body in air minus weight of the body in liquid. In this case, weight of the body in air was 5 Newton and weight of the body in the liquid was 4 Newton. It means upthrust is equal to 1 Newton. It can be represented symbolically this way also: U equal to W air minus W liquid. But at this time, I want to explain very shortly why a liquid exerts a vertically upward force on the body, which is called upthrust. Let's have a little explanation about this. Let's say this is a vessel. It contains water. If a body ABCD is taken in it, then we can expect that water exerts pressure from all the sides. Let's say this is the pressure acting from the side AD, and this is the pressure acting from the side BC. And we know that pressure equal to force by area. Pressure acting from the surface AD is equal to pressure on the surface BC, because both the surfaces are at same depth. Pressure is equal, P is equal, and both of them have same area also. AD and BC has same area. If pressure and area both are equal, then certainly force acting on AD and BC are also equal, but they are acting in opposite direction. That's why they cancel each other. Resultant force is 0. In the same way, force acting from the front side and back side is also equal and acting in opposite direction. That's why resultant of these two forces is also 0. Till now, the resultant of all these forces is 0. But what about the surface AB and CD? Pressure acting on AB and pressure acting on CD are equal? No, because AB lies at less depth but CD lies at greater depth, and we know that when depth of liquid increases, pressure also increases. It means pressure acting through CD surface is greater than pressure acting through the surface AB. P is greater at CD. But what about area? Area is equal in both the cases. Area of AB and CD are equal. Even after being equal area, why pressure is more on CD than that of AB? Certainly force acting on the surface CD should be more than AB. And if we consider the force acting on the surface AB is F1 and force acting on the surface CD is F2, then F2 is greater than F1. If F1 is reduced from F2, then we'll get the resultant force which acts in the vertically upward direction, which is upthrust. That's why we can say that upthrust U is equal to F2 minus F1. This is the region of upthrust. Okay, let's have question. This is a diagrammatic question. In the given diagram, an object is shown in the liquid. Yes, and question is, in which of the given surface pressure of liquid is maximum? We know that it is on CD because it lies at greater depth. That's why pressure of liquid is maximum on CD. On which surface pressure of liquid is more among AB and AD? Write down with region. We have to compare pressure acting on AB with the pressure acting on AD, and we have to give region also. Certainly, the pressure on AD is more than AB because the surface AD lies at greater depth than that of AB. So, pressure on AD is more, it lies at greater depth. So, we can write this way: pressure of liquid is more on AD than AB because AD lies at the greater depth than AB. Now let's have another question. Force acting on the surface of the body by the liquid is shown in the diagram. Which of them is called off thrust? Here force acting is shown with the help of this arrow from all the side, and which of them is called off thrust? We cannot say this one particular, this one is off thrust. We have to say this way: if we reduce the force acting on AB from force acting on CD, then we'll get off thrust. That's why we can write this way: we'll get off thrust by subtracting the force acting on the surface AB from the force acting on CD. Let's have another question. Write down the factors which affects off thrust. What are the factors? There are three major factors. First one, weight of displaced liquid. Off thrust depends upon weight of displaced liquid. Okay, it can be understood very nicely with the help of a diagram. Let's say we have a container which contains water, and if two bodies are dipped into it, look at these two bodies. First one is bigger than second one, and certainly the volume of first one is greater than volume of second one. So first one displaces more water than that of the second one. That's why weight of displaced liquid in case of this first one is more, and weight of displaced liquid in case of second one is less. That's why here we'll have more off thrust, here we'll have less off thrust. Okay, let's have another factor on which off thrust depends: density of the liquid. If density of the liquid is more, off thrust will be more. We can take example also. Look at these are the liquids. Let's say there are three liquids we have taken. One is aqueous solution of salt, another pure water, another kerosene. We know that the density of aqueous solution of salt is greater than pure water, and density of pure water is greater than kerosene. If a body which has greater density is placed in aqueous solution of salt, it will sink in this solution. If the same is placed in pure water, here also it will sink and here also it will sink. But the off thrust acting on the body by the first liquid, this is if A, and second liquid off thrust is if B, and third liquid if off thrust is C. And if we compare A, B, C, which are off thrust exerted by this liquid, then what is found? A is greater than B and B is greater than C, because density of salt solution is greater than the density of pure water, and density of pure water is greater than the kerosene. So off thrust in the solution of salt, that is A, is greater than the off thrust in pure water, that is B, and off thrust acting on the same body in kerosene is C, which is less than other two. This way we can say that off thrust depends upon density of liquid. More the density, more the off thrust. Let's have another factor: volume of the body immersed into the liquid. If more volume is immersed into the liquid, then it will experience more off thrust. We can understand this with the help of a diagram. Look at this. The same body is here immersed a little only. Here the same is immersed a lot. In this case, the reduction of weight is found to be more in second case than that of the first. If reduction of weight is more, it means off thrust is more. That's why when a body is immersed more into the liquid, then it will experience more off thrust. So here we have less off thrust, here we have more off thrust. Okay, let's have another question. Why it is easier to pull a bucket of water from the well until it is inside water, but difficult out of water? This is a common experience, daily life experience. We have to be very clear that both the air and water exert off thrust on the body. Off thrust of air is equal to weight of air displaced by the bucket, and off thrust in water is equal to weight of the water displaced by the bucket in water. So we can answer this way: fluid exerts an upward force, that is off thrust, on the body immersed partially or completely into it. Upthrust is the force which reduces the weight of the body. Since upthrust of water is very high than the air, so weight of the water filled bucket is less in water than in air. Therefore, we feel easy to pull the bucket in water but difficult in air. Okay, let's have another question. Among two bodies A and B, which one experience more of thrust? This is the diagram. Looking at the diagram, it is very clear that A experience more of thrust, but how to write? This way. A will experience more of thrust because of thrust depends upon the weight of the displaced liquid. Volume of A is greater than the volume of B. So A displaces more water than B. Therefore, the weight of displaced liquid is more by A. Hence, it experiences more of thrust than B. Okay, let's have another question. This is a diagram given. And what is the question? As shown in the diagram, a body is first dipped into water and later into the saturated solution of salt. In which case, the body experiences more of thrust, give reason. Certainly, we know that in case of B, the body experiences more of thrust because the density of saturated solution of salt is more than water. Okay, we can answer this nicely this way. In second case, that is in case of B, it will experience more of thrust because of thrust is directly proportional to the weight of displaced liquid. In case of B, the same volume of saturated solution displaced by the body has more weight than the same volume of water in case of A. Hence, the upthrust is more in case of B. Okay, let's have another question. It is easier to lift a heavy stone inside water than air. Why? It is similar to the bucket of water. When inside the water, it is very easy to pull, but when it comes outside, it is very difficult to pull. In the similar way, we can answer this way. When a body is immersed in a fluid, then the fluid exerts a vertically upward force on the body called upthrust. Upthrust acts against the weight. Since upthrust of air is very less than the upthrust of water, so weight of the body reduces a lot in water than in air. Therefore, it will be easier to lift a heavy stone underwater than in air. Okay, I told you answer of different questions. Now I want to stop this. Now in next class, we'll go through more question answer. Okay, thank you.